Okay, I want to do one last example with you guys where we've got variables on both sides of the equal sign, and I'm going to make it look a little bit different this time, where instead of having everything as nice integers or decimals, I'm going to throw those fractions back in there because I know you guys are afraid of them. But as I've said to you several times throughout this year, fractions are friends, right? Decimals are the ones that really are evil because now you're relying on that calculator. I want you guys to be able to do this without, okay? So I'm going to write up these two fractions. I got 3f plus 1 over 6 is equal to 3 plus 2f over 3. And again, this is an issue because I've got variables on both sides, and it's even harder now because I've got those fractions. Okay, so I could use my distributive property, and I could make sure that I divide each thing up top by what's in the bottom. So if I go 6 divided by 3, that's the same as 1/2, so I could have 1/2 f plus 1 over 6. And on the other side, if I do 3 divided by 3, I get 1 plus the 2/3 f, right? And simply that's just taking each term up top divided by what is in the bottom of our fraction here, right? So it's everything in the numerator divided by what is in the denominator, and really that's all I did to get these different numbers, okay? So once I've got everything written out, okay, I need to get my variables onto one side. Okay, so I got 1/2 f and I got 2/3 f. 1/2 is 0.5 and 2/3 would be 0.6 repeating. So 2/3 is my bigger of the two fractions. So I'm going to get rid of my 1/2 f from both sides. Now it works out really nicely on the left. They cancel out and I'm simply left with 1 over 6 is equal to 1. But this one is not as obvious right off the beginning. 2/3 and 1/2, they don't have a common denominator. So I'm going to rewrite that, and I'm going to think of it instead as 4 over 6f minus 3 over 6f. And I do that by finding my equivalent fractions. And this here gives me 1 over 6f. Okay, so I'm going to instead bring that out and have it as plus 1 over 6f. Okay, now I'm going to subtract both sides by my constant of 1. So I'm going to get rid of that 1 from both sides. Okay. On the right hand side, that's nice, they just cancel. On the left, if I had 1/6 and I took away 1, that would mean I'd take away 1/6 to get to 0, and there would still be 5 more sixths to take away. So I have negative 5/6, which is equal to 1 over 6f. If you don't believe me, then by all means, feel free to do this and find your common denominator and subtract them. You're still going to get negative 5 over 6. Okay? So my opposite is to multiply both sides by the reciprocal of my coefficient. So I'm going to flip my coefficient upside down, and I'm going to multiply both sides by that 6 over 1. On the right hand side, these guys cancel out. On the left hand side, the 6 is actually cross-reduced, which is nice, and I'm left with, in total, negative 5 is equal to f. Okay, so that wasn't so bad, but it was still a lot of work with the fractions. I'm going to verify to make sure we have the right thing, and then I'm going to show you actually a way faster way that we can do that. So I had 3f plus 1 over 6, and I had 3 plus 2f over 3, and we said that f should be negative 5. So let's substitute our value of negative 5 back in. Okay, so I now have 3 times negative 5 plus 1. I don't know what happened with my smartboard there. Decided not to like me. Okay, so we're going to divide both, we're dividing by 6. That gives us negative 15 plus 1 over 6, and that's the same thing as negative 14 over 6, which we could then write as negative 7 over 3 in lowest terms. Okay, on the other side, we've got 3 plus 2, and instead of f, we're going to fill in that value of negative 5. And so we've got 3 plus negative 10 over 3, and 3 plus negative 10 gives us negative 7 over 3. And there we go. both sides end up equaling the same thing. So that's not so bad. Okay, we got a nice integer answer, which made life a little bit easier. But that was a lot of work to get our equation there. We had to do a lot of work with fractions. And again, I know you guys would like to avoid them if you can. So just bear with me. I'm going to do the exact same question again, but I'm going to do it in a way faster way. If you guys don't like working with fractions, get rid of them, okay? And the easiest way to get rid of them is to find a common denominator. So a common denominator for 6 and 3 would be 6. So I'm going to multiply both sides by 6. Now, when you do that, make sure that you wrap your numerators in a set of brackets because everything would be needing to be multiplied by 6. Okay? Now, when I'm doing that on the left-hand side, I'm going to multiply everything in the brackets by 6, but then I also have to divide everything in the brackets by 6. And it doesn't matter what order I do that in. So I could actually multiply by 6 and then divide by 6. I'm just thinking of it as 6, then divided by 6, then times by what's in the brackets. So I'm going to divide both sides. I'm going to do the exact same question again, but I'm going to do it in a simpler way. So I know you guys really don't like working with fractions, so my advice to you is going to be, let's just get rid of those fractions. So if I've got a denominator of 6 and a denominator of 3, I'm going to find their common denominator, which is 6. So my first step is going to be multiplying both of the sides of my equation here by that common denominator of 6. So now I got 6 times, inside the brackets I got 3f plus 1 divided by 6. So I'm taking everything in the brackets and I'm going to times by 6, and then I'm going to take everything in the brackets and divide by 6. And really that just cancels itself out. Right? Take anything and times by 6 and divide it by 6 again and you're back to whatever you started with. Because I'm allowed to multiply and divide in whatever order I like, I can actually look at these two 6's first. So if I'm going to do times by 6 and divide by 6, they really just cancel one another out. They just become 1s. So what I'm left with on the left-hand side of my expression is 3f plus 1. That's actually nice and simple. I got no fractions this time. If I do the same thing on the right-hand side, and I look at the 6 and the 3 first, well, 6 divided by 3 is really the same thing as 2 divided by 1. So instead of multiplying everything in the brackets by 6 and then dividing it by 3, I'm just going to skip that step, and I'm going to start by simply multiplying everything in the brackets by 2. Doesn't make sense to multiply it by 6 and then divide by 3 because it's going to be the same thing as if I just multiplied everything by 2. Well, now all my fractions are gone and I'm just working with integers, so this is nice and simple. Multiply into the set of brackets using distributive property. So we've got 3f plus 1 is equal to 6 plus 4f. And then I need to get all my variables onto one side. 3f is smaller than 4f, so I'm going to subtract 3f from both sides. And that gives me now 1 is equal to 6 plus 4 minus 3 is 1, so I would get 1f. And if we just have one of a variable, we erase the 1. Okay, we just write the variable down. Okay, and then I'm going to subtract 6 from both sides. And that gives me negative 5 is equal to f. And that's the exact same solution that we saw on the board previously. Okay, I'm going to do one more quick one using that same idea. Okay, it's going to look a little bit different. So you might see it where instead of it being written as a full fraction, where I have a fraction as my coefficient in front of the set of brackets. Okay, but the same rule is still going to apply here. So if I've got 1/5 multiplying into that set of brackets with 4x minus 1 is equal to 1/4 multiplying into that set of brackets with 3x plus 1, I'm going to look at my two denominators. My two denominators, 5 and 4, have a common factor, their lowest common multiple. Sorry, not a common factor, the lowest common multiple, so common denominator is 20. So I'm going to multiply both sides by 20. If I multiply both sides by 20, my 20 and my 5 they cancel one another, and I'm left with 4 and a 1. On this one, my 20 and my 4 cancel, and I'm left with a 1 and a 5. So now my denominators have disappeared, and I'm left with 4 in front of this set of brackets, 4x minus 1, and I'm left with a 5 in front of this set of brackets, 3x plus 1. Okay, well, now I'm going to use distributive property to multiply into my brackets. So I've got 16x minus 4 is equal to, on the other side, the 5 multiplies into the set of brackets, and I have 15x plus 5. Okay. Looking at my two coefficients on x, I've got a 16x and a 15x. 15 is clearly the smaller of the two, so I'm going to subtract 15x from both sides. That leaves me on the left-hand side, I have x minus 4 is equal to, and on the other side I just have 5. And then I'm going to add 4 to remove my constant from both sides. And now I have x is equal to 9. Okay, so nice and simple. I was able to get rid of all those fractions just right at the beginning by finding that common denominator. Okay, even if I was to go back and verify, okay, so we had 1/5 times 4x minus 1, and we had 1/4 times 3x plus 1, so go back to the original equation before we started messing with it. So I had 1/5 times 4 times, and I'm going to fill in my value of 9 instead of x. Okay, and so now I have 1/5, 1/5 times 36 minus 1, and that becomes 1/5 times 35. And 35 times 1/5 is the same as 35 divided by 5. And that gives me 7. On the other side, I got 1/4 times 3, and I'm going to substitute. I'm going to bring that 9 in. You've got to be careful not to open Spotify with my marker. Okay, so 1/4 times 3 times 9, which is 27, plus my 1. 27 plus 1 is 28. 1/4 times 28 gives me 7, because it's the same thing as 28 divided by 4. And so we've got 7 on both sides. So even though we've got fractions, there is a way for us to remove those fractions by multiplying both sides by that common denominator. That should probably help ease some of your concerns related to the fractions. So hopefully you guys are able to do this. If you've got a MathLinks textbook, this would be section 8.4 if you want to go in and try any of those questions. They should look pretty similar to any of the examples I just gave you in the last two videos. All right, thanks guys, bye.